Hi, this is Jonathan Dodge, Principal Applications Engineer at United Silicon Carbide. And in this video I'll be talking about the two-level voltage source inverter and some of the new features in version 2 of FET-Jet Calculator. So first off, we notice that we have a control chart with a control signal compared against a carrier waveform and a circuit diagram. And then we have the per loss, per FET loss chart, and then temperature chart over on the right. And then as before, we have input parameters, but something new is now we have a modulation selection. So we have sine triangle modulation. This is what was used in version 1 of FET-Jet Calculator. This is where we compare a sinusoidal waveform against a triangular carrier waveform and compute the losses. And with sine triangle, we can have any number of phases, so you can increase or decrease the number of phases, and FET-Jet automatically takes into account the power loss based on the number of phases and the power that you've entered, and will not allow zero or negative number of phases. So let's go back to 3 phases. And the other thing is, let's just see what happens if we type in a voltage that would be out of range. So this is 300 volts line to neutral, and that's not achievable with an 800 volt DC link. So it tells us what the limit is, so we can type that in. Then the error message goes away. If we scroll down a little bit, we'll see the modulation factor of 1 here. We're right at the limit, and that means that this would mean the voltage control signal peak is lining up with the peak of the triangular carrier waveform. So that's the definition of modulation factor 1. Okay, so now if we go to space vector, you'll notice that the switching losses and conduction losses, they all look the same, and in fact there's only a very slight difference in power loss between sine triangle and space vector. Well, there are some significant differences in how the inverter operates. So now using space vector, and this is true also of discontinuous PWM, because that's also a space vector type, the phases are no longer independent of each other as they are with sine triangle. So therefore, if you try to select anything other than 3 phases, you get a warning message. So these are 3-phase specific modulation methods. And the other difference is now we can actually have a little bit higher, so we go to higher AC voltage. There's no warning until we get up too high, and then it'll tell us what the limit is. And if we scroll down, we'll see our modulation factor goes up to 1.15, and here we're above that, so we're getting the warning message. So let's go back to 230 volts, so 400 volts AC line to line RMS, and we'll take a look at discontinuous PWM. So with discontinuous PWM, we have the control signal that actually tells the top FET here at the top of the waveform to stop switching and just stay on for 60 degrees out of the 360 degree line cycle. And then at the bottom of that control waveform, turns the top FET off and keeps the bottom FET on. Okay, so this is useful to decrease your switching loss. It will slightly increase your conduction loss in the FET that's on. It's going to have a little higher loss, but the reduction in switching loss that typically outweighs that by quite a bit. So this is very useful, especially if you're operating near unity power factor, either +1 or -1 power factor. So in other words, as inverter or as a rectifier mode. So let's say we want to compare the losses, and we'll use discontinuous PWM in an active front-end rectifier at 22 kilowatts, and we'll keep 230 volts AC line to neutral, and everything else the same. So here we have total loss of about 211 watts in the inverter. rectifier, I guess it should say. If we go to Vienna rectifier, it has all the same parameters already entered in. And we have about 187 watts. And then we go to 3-level TNPC, again with the same parameters. We have about 172 watts. So in terms of total loss, the 3-level TNPC is the winner using discontinuous PWM. So hopefully this is useful to you. Appreciate any feedback. Thanks for watching.